We are up and running. Hello and welcome back. Episode, I believe, 13. Yeah, episode 13. I apologize. I have not been on for a while and doing a lot of repairs. I've just been extremely busy, especially with work and a lot of other things. And, as you can see, my allergies have just literally been destroying me. So, yeah, I mean, a lot's been going on, and I know it's been a little bit of time since I've made any of these videos, but we're going to get into it today. So today we are going to be doing a SUNFIRE, and this is the HRS 12 that was sent in. Oops, there we go. And this amp needs a repair. So typically on these amps, if there are no fuses blown, it's a recap. If the fuses are blown, it's usually caused by the caps, and by then it's been, too long with the bad caps in there, and they've caused other things to fail. So the first thing I always check is I check the fuses, and they're nice and buried in here. Let me get my little poker stick, and here's the first fuse right here, and then the other one is kind of buried back behind this power connector, and it's down in here. And both of these fuses are good. I can see them. There's no black spots on the fuses, so chances are this one is beginning to fail but hasn't yet fully failed. It's almost always due to the caps. The caps leak from just being plugged in and powered on 24/7. These amps do have a power switch. Most people just leave it on, hook it up, and it stays like that for its entire life. That's the number one problem. They do have a standby and an auto on-off feature, but in order for that to work, the power supply still needs to remain powered on. I do not. This one might have a relay in it. I'm not sure. No, I don't think they do. I don't think this one has a relay. But if they have a relay that controls the power supply, that's a little different, because then you have a low voltage supply that completely disables the main for the rest of the system. Amplifiers that have that, generally you can leave plugged in, and when they go bad, it's usually just the low voltage supply. This one, I don't believe, it's been a while since I worked on one of these, but I don't believe they have a relay in them. I already know there's power supply problems with this because I can see one of the caps is bulged. So we're going to go through, we're going to recap it, and we'll see what happens. If it comes back to life after a recap, then it wasn't too bad of a repair. If it doesn't, then we got some troubleshooting to do. Interesting thing about SUNFIRE is when Bob Carver made his original, I think they call it down tracking or down converter, his original design, they kind of duplicated it on all of their models. So almost every SUNFIRE amp uses the same topology and the same circuitry. There's not a whole lot different between them. There's a little ant on here, and he just doesn't want to die. Got him that time. But so once you work on one SUNFIRE, they're all pretty much very similar, and if you understand how they work, you can kind of troubleshoot them. Unfortunately, there really are no schematics per all the different models, so you kind of have to understand and learn how the circuitry works to troubleshoot them. I'm not really that great at it yet. My main focus is on clip stuff, but I started dabbling on these because you can find them dirt cheap at like garage sales and online, and they're not really too bad to fix. So that's how I got started, and now I have a ton of them that need to be repaired. But hopefully we'll get to them. I plan to keep doing videos. Like, I don't like being away, but sometimes life happens and you can't really control that. So these connectors are kind of a pain to get off. Pair of pliers, especially little needle nose, make it a little easier. These are also a pain to work on. This board is glued in, and it's got like a really nice silicone glue on it. So unless the RCA input connectors are damaged, I generally leave it alone. This board stays in. The pots have little notches in the sides of them, so if you need to get some deoxit in there to clean them out, you can. I do have replacement pots for these. I believe these are alpha pots, so if I have to, I can replace them, but generally a little squirt of deoxit cleans them right up and it's no problem. So I'm going to start off with the actual amplifier board. This is the input board, this is the amplifier board, and this is the filter for the power supply. And you can see these don't use like a switching supply, they use a massive transformer. So it's a little bit different from some of the other ones, but the amplifier section is pretty much the same. So on the Super Juniors and the TSEQs and some of those other versions, they'll use it's really not a switching supply. It's just a tracking supply, like high voltage DC. This one, they step it down a little bit with a transformer, and that's how they do it in this mod. I think that's it. It's probably a little. I don't know. I can't see it being more cost effective because transformers are fairly expensive. I don't know why they do it this way on that one. I'd have to do some research on that. If anybody knows, leave a comment in the comments down below and let me know why you think they use a transformer versus using just a higher voltage tracking supply. And unfortunately, I don't really know what this transformer is putting out. I do know it puts out the auxiliary voltages, but there are no schematics for this. And I mean, I could, pin out the leads and find out what the voltages are coming out of it, and I'm sure I could figure it out a little bit better, but there really is no need to. I know how to fix them and make them work, and that seems to be good enough. So gotta cut off all these zip ties. They love using zip ties too. I like that. It keeps them clean. They have a lot of filters in here too. I haven't quite figured that out yet. This is a noise filter for the ground, and then they have a filter on the output, which they have it wired in common mode. So I'm wondering if they had some hum or some buzz that they were trying to eliminate out of this, and they did it by putting a torrid in there and using that as a filter. I don't know. Interesting. Very interesting. But so we're going to start with the amp board, and these have their own set of challenges. Getting them apart is kind of a pain. They put glue on all the screws, so you just got to kind of work through it, and that's that. I'd say the hardest part of this repair is probably taking it apart. And oh yeah, these little screws on here, they're double nutted, some of them, so you have to make sure that you take the nuts off first. I made that mistake before, and I actually stripped one of the screws. But this little nut on the ground here, and you can't get to it with a nut driver, which is really frustrating. So you just gotta kind of manually work it off with a small pair of needle nose. I don't know, maybe if I had a really thin nut driver I could get one in there. I should probably just make a tool to do this, but that's really not that critical. So once you get that loosened a couple turns, you should be able to get it out. But you have to loosen that first. If you don't loosen that, you will not get it out. I guess that's tip number 1 for this guy. And the reason they do that is to hold that, I guess it's a grounding strap going to the other board, which I really don't understand, because both boards are secured to the plate, and I mean, it's aluminum plate. You would think you would get enough conductivity through the plate to provide grounding, but they added an extra ground. Why, I don't know. That's above my pay grade, I guess. So yeah, get that ground wire off first. You got to do that, and then you can proceed to take the rest of the screws out that hold the amp board on. Now when we're reworking the input board, we're going to leave that board in and try to work around it. And there's not that many caps on there, so it really isn't too bad. One of these days I'm going to get an electric screwdriver too to help speed things up. Now, all of these FETs have nuts on them too, which is kind of a pain. So you might have to take the little filter output board off just to get it out of the way so you can access those nuts. But once you get in there and get them off, it's not terrible. These have a couple auxiliary boards that you have to be careful removing. The goal is to not have to replace any through holes. That is what I would call a successful repair. If you have to replace through holes, then it might be successful, but you wasted a lot of time because you didn't do it right the first time. And I believe these have separate lock washers with the nuts, so don't lose the lock washers. Actually, they have a lock washer, a washer, and a nut. Magnetic screwdriver is your friend. And there are 3 of those. One is a driver for the mains, and the other are the main outputs. And I guess this is a lower power amplifier because it only has 2 FETs for the outputs, where most of the other ones have 4 or larger ones. These are much smaller than the other series, so that could be part of why it doesn't need such a large supply. And we'll check those for shorts, but if there's a fuse that's not blown, chances are that's pretty good. I'm guessing that this started to develop hum, and the owner turned it off, and he said, hey, my amp is going bad, I need it fixed, I'm going to leave it off and not try to kill it any more than it already is. Which is a smart move, if you ask me. Alright, screws are out. Now we have to take off the little bridge that holds the T0 220 FETs in. That's part of the tracking supply. Again, these are screwed in with nuts. I don't. PEMs must not have existed when they made these. I don't understand why you wouldn't just put some PEM nuts on there and eliminate nuts and star washers altogether, but I don't know, maybe it comes down to aesthetics. They wanted the back of the amp to look appealing, even though in most circumstances it faces the wall and nobody ever sees it. That one I don't understand, but I think it would have been a much better design if they used PEM nuts and got rid of all this extra stuff. Don't be afraid to get in there with some pliers and these things are hard to work with. They are extremely heavy, and they do have a mind of their own. I'm actually going to get out my kickstand, make it a little easier on myself. There we go. If you don't have an amp kickstand, get yourself a circular saw or a table saw and make one. It will make life much easier, instead of fumbling around like I was a few minutes ago. But these have some kind of green plastic melted on them to try and keep the screws from coming loose. Seems to be somewhat effective. How necessary it is, I don't know. Usually lock washers are enough. I do like this design here. This little clip that holds down all the FETs with the little fingers. It's pretty effective. I just wish they had nuts that were like welded onto here so I could just unscrew it. Just that little tiny bit of extra would have made it that much better. I'm going to guess, though, that these were... Let's find out where this was made. I'm guessing they were made overseas. This is probably when everybody had to do that to become competitive. It does not say, or at least I don't see it readily jumping out at me. Oh, there, here it says. Designed by SUNFIRE in the USA, manufactured under license in China. There we go, for SUNFIRE. So yeah, this is when they needed to become competitive or remain competitive, and they had to outsource their designs like everyone else because manufacturing in the US was too expensive. And that's why you have cheap Chinese capacitors in your amplifiers, because they were made in China. Nothing against SUNFIRE. I mean, they did what they had to do to stay competitive. Everybody did it, you know. You either get on the bandwagon or you fail. It sucks, but that's the way it is. Alright, we lost the thermal pad. It's getting goo all over my desk, and everybody that's watched at least one of my videos know how much I love thermal adhesive. It's my favorite stuff in the world. Alright, so we will start with the amp board. And yeah, I can definitely tell that this is a smaller supply, because on the MK2 and some of the other amplifiers, they have 3 IRF 640s on each side, and this one only has 2, so this one just doesn't drive as much current, is what it boils down to. So we're going to recap this board. It actually doesn't look bad. I don't see any of them bulging, but we're going to do it anyways because that's what this repair calls for. And we want to make sure that we're replacing all these Chinese parts with something that's a little bit higher quality. So, let's get into it. Let's heat up the solder sucker. I haven't turned this thing on in so long, I don't even know if it'll heat up. These two are a pain. I really don't like these little add-on boards. Or I wish the caps were on the main board and they left the add-on boards alone, because there's no easy way to get them out. I mean, I suppose I could get in there with an iron and solder wick them. I don't know, maybe we'll try that. I've never done it that way, but maybe we'll try them, because the way that they install them is they just have PCB pads on the main board and on the little daughter board, and then they just wash the solder up to make the connection, and then they cover it with this glue to hold it in place. I mean, I understand they were probably low on space, and that's why they did that, but it makes it a pain to recap those boards. So I will see if we can come up with a different way to do it. You can see they have some nice high current jumpers in here. All in all, though, this board looks pretty good. I mean, nothing is burnt. Doesn't seem to be anything wrong with it. I'm sure the caps are slowly starting to die. Maybe not on the actual amplifier board, but I saw some other ones that were leaking, so I know that there's a problem with that board. Man, I can see my head in the camera here. I need a haircut. I'm going to have to tell the wife I need a haircut today. I'm too cheap to pay for haircuts. Especially when it's $15 for a buzz cut. And some of these caps are glued in. think they were terrified of things coming loose. So they just randomly splattered glue on stuff. But the glue comes off really nice on these. It's not like working on a klipsch where you got to like dig at it and pry at it. And it's like a silicone-based stuff, which doesn't become conductive. And that is a key thing to note. I have never seen this glue burn. I've never seen it short anything out. So they at least spent a little money there to make sure that they wouldn't have any of the glue problems that most of the other manufacturers experience. So that is worth noting. I hope I have all these caps. This is a 47 200 volt. I think I have some of these. I recently stocked up, so I have 250s. Let's see if I have 200s. If I don't have 200s, they're going to get 250s. You can always go up in voltage. That doesn't hurt anything. I've been trying to commonize most of my caps because I use so many different caps between models. I do have a 200. UPW series. And that's a UPS. I only have one of each. I'm going to have to order some of those. I'll put that on my list. I like the UPS. But these UVZ ones, they're Nichicon caps. They're still really good caps. So we will use those. And they're still, the original ones are, okay, so they were 105C rated. That's pretty good. The replacements are also 105C. But we will replace these two. Make sure our polarities are marked. I still find it interesting that all the manufacturers do it differently. Some of them mark the negative, some of them mark the positive, some just use the pads on the bottom of the board, even though the capacitors are all industry standard. These ones do not use square pads for identifiers, they just use silkscreen, so they have a little plus on the top. Make sure you keep your polarities correct. And I'm sorry, this is a UVY, not a UVZ. Nichicon. Doesn't matter though. I have two of them, and that's what matters. Actually, you know what? I'm going to hold off on those, and I'll tell you why. I know I need to order two caps for this that I don't have, and that's the main input caps, because these use shorties on them. And I do not have those shorties in stock, so if I have to order caps anyways, I might as well just get the UPS caps and put those in. And I'm just double checking to make sure I don't have them in the zillions of caps that I have everywhere. Need to get a bin and mark the bin for short style capacitors. Yeah, so it's this size that I need in 200 volt, and these are the ones that I have, so they're a little bit bigger. So I have to order those. Actually, wait, maybe I don't. Do I have them? 470, 200 volts. Maybe I do have them. What are these? Oh, those are 1,000. Never mind. So they're 1,000 microfarad shorties. And I have 820s. I have everything but 1,000 in short. I have them in 200 volt. I don't know. We'll hold off on that. I'll replace all the other ones for now. I need to order some parts anyways, so I would rather put the UPS series in there. UVZs are good. I'm just trying to transition away from them. The UPS has a much longer rated life. They're a little more expensive, but sometimes you can't do that. It really depends on the overall size of the cap. Certain caps just don't come in a specific size, and I can tell these are garbage caps just because they're so light. Like, I don't have my scale down here, but if you compared these two, the Nichicon is about double the weight of this one. So I'm guessing it's just all around much higher quality. Sometimes these ceramic caps can have their leads shorted, so it never hurts to check on that. I don't know why they have those little nibs that kind of like point together. It would have been better just to sit them flush on the board. I was working on an amp one time, and that was the problem, and it took me forever to find it because I wasn't looking for it. And I'll overnight these parts. Unfortunately, it's going to be a two-part video, but I'm planning on doing a marathon tonight. Like, I haven't been doing like repairs. Like I said, a lot's been going on. I haven't been feeling that great. My allergies been nuts, so hopefully I can get a decent amount of repairs in tonight. Alright, 4.750 volts. Plus this will be good too because I need to track my inventory and see what I'm running low on and fully restock up. But this amp will definitely have new life once it's has the recap done. It'll be back in business. It'll sound great. And if I can convince the owner to turn it off, it'll last a very, very long time. I usually put like a little note in there when I send them back, like, hey, you know, like, turn this thing off if you can. They have those Wi-Fi controllable outlets now. I mean, you can get them on Amazon for a couple of bucks. It's I mean, really beneficial to have one. Or you can get the outlets that are controlled by your stereo system. I mean, those are pretty cheap too. But whatever you do, just power your equipment off when you're not using it. If nothing else, just do it to save your electric bill. You'd be surprised when you shut everything off. You know, 20 devices that you usually leave powered on, that adds up over time. It'll lower your electric bill. The only thing I really don't shut off is my computer. But my computer's pretty energy efficient anyway, so when it goes into sleep mode. Granted, it's probably not good for the power supply, but it's really the only thing I don't shut off. And again, check the polarities if you're not sure. And you'll notice some little boogers get on the board. That happens. If you can't get them off with the iron, they'll scrape off with your fingernail. They don't stick to anything. And I brush these all off before I put them in and clean them anyway, so just make sure you get the little buggers off so they're not floating inside of the amp. It won't hurt nothing. Most of these small ones are 4.7s. I think all the orange ones are. Sometimes they're hard to get out. I don't know why. They have little boogers on the end of them or something. 4.750 volts. It's one of the most common caps used in almost all audio equipment. You need to have a good supply of those if you're going to be doing these repairs. I don't get a lot of these in. think I've done 4 of these. I have 2 of them were the ones that I've owned. I don't know how popular they are or were. They seem to be a pretty robust design. The Super Juniors seem to fail a lot more. Super Juniors and Architecturals and the MK2s. But it's unfortunate to say it all boils down to cheap Chinese components. I mean, even good capacitors will fail over time if left on, but they generally have a much longer rated life. Alright, 220, 25 volts. I know it uses 2 different sizes of these, so you kind of got to pay attention to that. And I am running low on these as well, so we are going to have to order some more of those. I'm going to actually make a list right now, and hold on one second, my wife is calling me. Okay. Wife's asking about dinner. That's important. Alright, I am going to make my little shopping list right now. Of course, I don't have any paper to write on. Why would I? We'll just go right to the cart. And these things use different diameters, so it's important to get that right. So I'm going on DigiKey. That's usually where I get most of my parts from. I like, their selection and their shipping. What I don't like lately is that it takes 3 days for an overnight order, but I guess you got to deal with that right now because of the pandemic and everything else. But we're going to make sure that I get a handful of these and everything else that I need to finish this and get it here as fast as possible. So these are, I'm going to say 8.3 in diameter. We're going to go Nichicon 220. And they are rated at, I think these are 25s. Yeah, 25 volts. And I want UPS series. I like UPS series. They're good caps. Making sure they all come in the right diameter. Yeah, 8 millimeter. Okay, so they have 2 different heights. They have 11 and 13. Height doesn't really matter in this application. These are 13s. So I will make sure I get the 13s. And hopefully, yeah, they have them in stock. That's good. Double check that that's the right height. 13 millimeter. All right, good. Let's get 40 of those. Actually, it's cheaper if I get, it's half the price if I get 50. We'll get 50. Stock up while we can. And I'm going to replace this one while I have it in, knowing that I have more on order. And I'm going to add those other two that I'm missing into my card as well, just to make sure I get them. So bear with me while I add my other missing caps there. Alright, I need to go back. I need, what are these? 47,200 volts. I'm going to get a bunch of these. And I'm actually going to double check to make sure I don't have those. Sometimes I have my spare parts bin full of parts and I don't even realize it. I have a bunch of 47-250s. Always gotta look, because $47,250 is a SUNFIRE cap. And you can put 250s in there if you need to or want to. Depending on what else I have or don't have, we'll determine that. If it's just one cap that I'm missing, then yeah, I probably will just use the higher voltage cap. If I have to order caps, then I will order the right one. It's gotten to the point where I have so many different capacitors, like this is just part of my overstock. But we're going to browse through it anyways. I'm actually going to put them on my shelf. And some of these are not even in the right bags. So I have a ton of the 47-250s. So if I have to, I will use those. But for now, we're going to continue where we left off. I'm going to order more of these in the right size because I do not appear to have them. All the ones I have are 250s, and those are used for the larger SUNFIRE amps. Maybe I'll reorganize and break them up by whether they're used in clips or not, but alright, let me get these added to the cart real quick. Stand by one more minute. 47 microfarad. 200 volts. We'll go to Nichicon. Try and match up the same height and diameter. These are 22 by like 12 or 13. So I will sort it by height or diameter. We'll do diameter first. Yeah, diameter is going to be 12. Lead spacing, I believe, is 5. So let's do lead spacing first. See what heights that leaves us with. 12.5 diameter. And they have a UPS in this series. 47, 200 volts in the height. In size we need, actually the height is 27. What are we on this one? That's a little higher than what we had. Let's see if we can get them in one of the maybe UPW series. Again, it doesn't really matter, but in some applications there's not enough room to fit them in there, so you're better off having the right size. let's see, they have UVZs. I generally only use 105C rated, unless I absolutely have to use something else. UVY series is pretty good. UVR series is pretty good. UVR is an 85C. UVZ is as well, but I like to get into the, over 1,000 hours if I can. The UPS were much taller in that series. I don't know why I can't select that. Let's clear our selections. In this case, I actually might go with one of the higher ones because I can't find one that has the rating that I want. So I can get 25 millimeters high, which is a little bit taller than these, but not too bad. But my time rating goes to 7,000 hours at 105C. That's a lot better. And that's going with a UPW series, and I've used those before. They're a little more expensive, but it is what it is. So I am going to order those. A few millimeters higher for much longer life is worth it to me. And if they don't fit, I can always just reorder the ones that I need to fit. So might as well get 50 of these too. Just stock up. We'll get 50 everything today. Why not? $50 of everything sounds good. Now I'm keeping all my spares and all the ones that I removed just so I know, what I needed to order and what goes where. The ones that I've already populated, I can throw those out. Those are garbage anyways. But that'll help me just to remember kind of what goes where. And I do have some pictures of some of these so I can kind of figure it out on the way. But I believe I'm going to have to order these too, because they're a weird size, and I believe I have to use Rubicons for these, because Nitricon I can't get them in the right size and height, and this is one of them instances where height actually does matter. If you go too high, the cap's going to be touching the other board, and you're going to run into problems. So, that's what you got to pay attention for when you're ordering replacement parts. You got to make sure that they're going to fit. So here we go. Let's continue. I'm going to do all the caps on the main board first. This is 220, 16 volts. I know I have some of them. And these are a little bit larger in diameter, but they will fit, so we don't really have any issues there. But you can see the difference. The lead spacing is off a little bit. Actually, maybe I'll order these too. Might as well get the right ones. I didn't realize I was this low on cap stock. Shame on me for not ordering parts sooner. All right, let's order some more parts. It's going to be a boring video unless I get back to doing some repairs here. 220. And the only reason I'm not doing that is because the lead spacing's off a little bit, and I don't like stuffing caps down in there. I want it to sit flat on the board. So as most of my videos, this will be a two-part. Alright, let's get our lead spacing first, and our lead spacing is, it's always hard to measure these. I'm going to say it's 2.5. Diameter's 6 point, whatever the number is, 6.3 I think. 6.3. You have two lead spacing options, 2.5 and 5. It's definitely not 5, so we'll go with 2.5 and see what's left. I don't think a UPS or UPW is not available in this series. So we will find some different ones. And there's all different kinds of, you know, I generally use general purpose because most of these are general purpose. I don't have, you know, detailed schematics showing me where they are in the path, but I mean, generally general purpose is good enough. If I knew it was in a sensitive part of the audio path, I would use one of the, you know, more expensive audio versions, but like these look the same as all the other ones. Like there's no markings on them that would identify them as something else. So we're going to try and find 105 C rated with the longest life, and we will then move on. And looking for parts is a pain, you know, like you got to put some time into it. You can't just, you know, grab whatever you see. Like, you know, I've talked to people and they're like, yeah, I'm ordering parts on Amazon, and I just shake my head like, you can do whatever you want to do, but I recommend getting quality parts if you're going to spend the time to do the repair. It doesn't really make a whole lot of sense to do, you know, quality work and then put garbage parts in there. So this one in the right size is going to be a UVZ. The picture shows it's a bent lead though. I'm hoping it's not. Yeah, it's just a bad picture. Alright, let's get 50 of those. I'm going to put this guy back in, just so I know where he goes. I'll just tack one leg down. Alright, this is another 220/16, and this is a 220/25, which I don't have any more of those either. Alright, well, that's it for this board, except for the two that are on the daughter boards. Let's try and get these out of here. I'm going to try and see if I can very carefully get the solder sucker just in there from the edge without touching anything else. I haven't done this before, so this will be fun to try and see if we can do it. And of course I got thermal paste all over me. Just make sure you don't, you know, you can touch the little rod here, but don't touch the coil. And that actually looked like it worked. I am quite surprised, but the part did come loose. And I know this is a, oh, this is a 470/16. I might have this in the weird size too. Let's see what we got. In these, the diameter does matter because it's, actually, maybe not, hold on. I remember I had an issue with the one up top. Let's pull them both out. I'm surprised that I was able to suck the solder out of there on an angle like that. I'm going to add a little bit of extra to this guy. Because if I can do that again, that just changed the way I repair these boards forever. It saves me a ton of time being able to do this. Even if I can only do one that way, it still saves a bunch of time. Wow, would you look at that? This is 470/16 on that one as well. So, alright, well, I guess if you have the right tool, you can do it. That's pretty awesome. Like I said, that just saved me a ton of time, not having to mess around with pulling those boards out. We're going to have to clip the leads to get them soldered back in, but I won't cry about that if none of you guys do. So we're just going to pre-clip them, just so we can get them soldered in there. Definitely observe our polarities. The larger ones do fit on here, and it's actually, it's marked for a larger cap. It does touch this little ceramic guy down here, but we can gently move him out of the way. Make sure that's not shorted against this resistor. But the larger ones do fit, so I'm going to put it in there. Again, make sure you check your polarity. Positive goes towards the FETs when you're doing this one. It's going to kind of bother me that it's touching that ceramic cap, and I don't really want to fold him. I guess I could fold him down and out of the way. This is where being OCD doesn't help you a whole lot. But this is only an 85C rated cap, so this thing's junk as is. Let's fold him down. I'm going to fold this cap down on the inside. Now it's not at risk of touching anything, and it's out of the way. And we're going to put a much higher quality cap in here. 105C rated at 7,000 hours. And you want a really good cap in this spot too, because the next tech that works on this, if they ever do, they will thank you for using a good cap in this section of the board. So we got lucky on that, and this is why making videos is kind of fun, because you learn new things, and I get to share these ideas, and I get to document it. So next time I do one of these and I watch this video, I'll be like, oh yeah, I can save a bunch of time if I switch over to the new way of replacing these. I don't know why I've never tried that before, honestly. It seems ludicrous that I haven't, but again, you know, just double checking. 470/16. Gotta clip the leads on this guy if we want any chance of getting the other one in. And this might be why I didn't do it, because this guy's probably going to be a little more difficult to get in. I might pre-clip these leads a little more, or bend them a little bit. Make sure you bend them the right way. If we can get them started, we'll be alright. I got one. The other one does not want to cooperate. Maybe this is why I never tried it, because it is going to be difficult to get this guy in there. I have two different things I can try, though. We're going to try this way first, see if I can get him started and get him through. And if that doesn't work, I'm just going to cut the leads to the actual length that they should be and see if I can sneak it in there and still have enough room to solder it. If I have to throw out a cap, so be it. I'd rather waste the cap and learn a new way to get these things in there than it's like performing surgery, you know. Alright, both leads are started, but it does not. Oh, wait, there we go. It popped in a little bit. There we go. It popped in. Cool. Cool, cool, cool. Let's straighten them leads back out before we solder it. So a little bit of little finesse. Takes a little finesse to get the second one in there. Is it worth it? Hell yeah, it's worth it. Make sure we are all the way in and seated flush on the board. We look good. Tweezers made a wonderful little holder. And we definitely saved a ton of time. Cool. I am happy with that. Saved some time, and we did a nice upgrade on this board. Alright. So we still have some caps, unfortunately, that I do not have in stock. That's frustrating. But let's move on to the next section of the repair. And I keep forgetting to leave my stream window up in case somebody wants to chat. Maybe a little cleanup too, because I'm getting kind of cluttered up here. These guys can go in the garbage. Alright, I know I don't have these big guys. Those are going to have to be ordered. I have them in 200 volt, but I'm going to order the 160s. Because I only have 2 of the 1000 volts, or I'm sorry, 2 of the 200 volts, and I know some of the Klipsch ones take that and they call for 200 volts, so I want to make sure that I get the right ones in there. You can take this board out and do the way, and I think I will for this repair, just because I want to make it as easy as possible to get to this board. You just got to be careful you don't melt the wires, but taking it out does help. The problem is some of these wires are really short, so you have to leave it in the board, and I'm not unplugging anything from the power terminals or anything. You can see they're covered in that silicone stuff. That silicone stuff is pretty nice. And you're really at no risk from that ever becoming conductive, so I leave it alone. So let's take the screws out of this guy. Make sure we don't lose our washers because they're stuck on the screwdriver still. And I can tell this is where the problem on this amp initiated. And I will share that with everybody. Now you can pull the transformer out too if you want to remove like most of this assembly, but there's really not a need to do that. So this guy is loose, and that uses 2 different size screws, keep that in mind. But just sliding this out of the way a little bit, you know, allows you to bend the wires and get a little more easier access to the input board. The main caps look good, but you can see that this guy right here is bulged. Let's zoom in. So I'm gonna guess this is the root of the problems. It's kind of hard to see on the camera, but it's definitely not flat like the other one. Maybe that's the best view. You can see it's just domed up just a little bit right there. The bridge rectifier probably got hot and cooked that guy, and that's the source of your hum, at least on this guy. So let's get in there and replace those. Do that part next. Take the big guys out. These are going to get replaced. Need some heat to get these things out because there is a lot of solder around them. Better have an iron that could pump out some wattage. And to add insult to injury, they fold the leads over. I promise any future repair people that I will not do that. I'll show you in a minute how that looks and how much of a pain it is to deal with. First you got to find where the lead is, because it's buried under a pound of solder. I get it, they wanted this to be a sturdy connection, but it makes servicing it a nightmare. Alright, let's see, let's cut the zip tie here. Always cut zip ties in between wires too. That's a little trick. If you have a bunch of zip ties on these wires, don't cut it so it's like across a wire like this, because if you slip you're going to cut the wire. Make sure you're in between the wires when you're snipping. Pro tip. So you can see these are snap-ins. You can't really see. Let's zoom in. I like my little zoom remote. Focus on the shiny stuff, camera. Right here. Right there. Come on. No, there you go. So you can see they're snapping caps, but they're folded over. So you got to get all this solder out of the way, and then the cap still isn't free. So you got to take a pair of nippers or something, and you got to break the remaining solder that's under it to fold the leg of it up. That's a pain. Like, why? I get it. Like, they don't want the caps to fall out, but if they put a blob of silicone in here, you don't have to worry about that anyways. So just makes it a nightmare to get these things out. By the way, I pre-discharged this board before I even turned the camera on, so if you are going to work on this, make sure that your caps aren't storing any voltage in it. That would be a bad day. Alright, number one is out. That gives us a little better look inside here to see what's going on. We've got a couple of hot resistors in there. We'll get a little measure on those to make sure that they're still okay. 2 bridge rectifiers. This guy we can even fold a little bit away. This resistor is probably part of the reason, because it probably gets hot. Like I said, you leave these things powered on, and it helps if I'm zoomed out again so you can see what I'm doing here. But yeah, there's a resistor in here and a diode bridge, and it's hard to see. But, anytime you have a power dissipating resistor next to a cap, it's a failure point. It's going to get your caps hot. And SUNFIRE loves to put resistors right next to capacitors. I don't know why. I don't know who made that decision. They should have put the resistors on the bottom of the board. There's plenty of room in here that would have helped dissipate some of the heat. I don't know what the reason is for it, but somebody made that decision. So we get the second big cap out. And like I said, I have to order some of these big caps too. I will not be ordering 50 of them though. These things are probably $6 a piece. Large caps are not cheap. This one's going to be a little difficult to get out because the bracket is in the way. Again, we got to straighten the leads. I got most of the solder out. You know, it's alright if you leave a little bit on there. It will break when you use a good pair of nippers to cut them out, but you just got to be careful that you don't do any damage to the board. Generally, the solder is weak enough to where it won't stick that good, but just be careful. Alright, here we go. And again, they use that nice silicone stuff so it's non-conductive, so you don't have to worry about shorts under here. If only they used higher quality capacitors, rated for 105C and not 85. Be better off. And again, like, just comparing the weight, this one is rated for a little bit higher voltage. Same package size though, but you can feel the weight difference between the two. Like, this is very light, where this one's about double the weight. So I don't know really what goes inside the construction of them. I know there's like foil and paper and electrolyte in there, but for some reason the quality caps weigh a lot more. So somebody knows that, somebody works in like the industry and they can tell me why good caps weigh more than cheap caps, please let me know, because I don't know, maybe they use thinner foil or somehow they make it cheaper, and I don't know how they do that. But you can tell the difference right away just by handling them. This cap right here is our failure cap. This is what caused the hum or the buzz. I'm assuming that's what the issue was with this one, as it doesn't seem to have any other failures. 85C cap right next to these two power resistors and two dial bridges, and these are all sources of heat. So in here is where you want, you know, a minimum 105C rated and something that has a nice long life. Clean up a little bit of the silicone. I don't have these caps yet to replace, so I'm going to add those to my order list too. But I generally don't glue the caps to the board. I will put some silicone in between them to support them, but I really don't see a reason to glue them to the board. They're already soldered to the board on the bottom side. And really, you don't even have to clean this stuff up because the new caps will kind of sit nicely in the profile. I just do it because I'm a little OCD and I'm used to doing it. I'm a creature of habit, what can I say? But you can leave this stuff on there. This is non-conductive. It will never be conductive, and you don't really have to worry about it. So keep that in mind. Alright, so our bad cap is 1000 microfarad, 25 volts. I'm pretty sure I have some of these somewhere. I know I've worked on these amps before and I've ordered them. It's just a matter of, since they're uncommon, I generally don't keep them all in the same area. I might be out of these too. I might have to order some more. I have 1000 at 16 volts. I know what's going to happen too. I'm going to order all these parts and I'm going to go into reorganizing and then I'm going to find them all and be like, oh, hey, here they are. And I'm going to have triple the amount of the ones that I don't need. That seems to be my my issue. But I'm still trying to get my work area organized. And in previous videos I showed you how many amps I have on my shelf. So it's going to take some time, so I'm not worried about it. And the extra parts will get used. And I do not think I have any of these at the right voltage. Check a couple of more bins, where I keep some of my oddballs. And then we're going to order these too. And I'm going to say no. So we're going to switch over to DigiKey and order these again real quick too. And I'm not sponsored by DigiKey or anything like that, so it's just a personal preference where I like to do my cap shopping. I used to like shopping at Mauser, but they don't do USPS shipping, and I like deliveries on weekends when I can get them, so I cross them off the list. I think it's ridiculous to pay FedEx and UPS rates for small packages that can fit in priority mail. But, you know, I'm sure everybody has a preference, or shipping is different in certain areas. So whatever works for you, that's what you should do. DigiKey works for me. Alright, 1000 UF, 25 volts. Let's get a few of these on order. And again, I'm sorry I don't have these parts in stock. It's been a little while since I've been down in the lab here. I couldn't even move yesterday. I was like on a sneezing rampage from my allergies, and like I have like bruising from it. It's terrible. I have a pretty high pain tolerance, but I mean that took me out. I was sore. Alright, we are going to do Nichicon again. I don't know why it has surface mount. We're going to do through hole. And this is one of the ones where the diameter is probably a little more critical just because it's kind of tightly packed in there, so I'm going to try and... These are about 10 with a 5 lead spacing on them. Should definitely have a little ruler. One of these little cheap rulers with some millimeter units on it makes life much easier. I'm hoping we can find, okay, so they have UPW series, which is my next choice after UPS, and then followed by UVZ and all the other ones. We're going to go with UPW on this. And the UPW is 5,000 hours at 105C. So definitely better than the 85C garbage that was in there. So we're going to go with those. And these are not cheap. So I am going to get, we'll get 20 of these. They're not as common, so. But you can see you have, you know, some high temperature components that are surrounding the caps. You know, so generally you want to keep these as far away as you can from, especially these resistors here. I mean, I know with the larger caps it's hard to do, but you know, any place where you have a concentration of heat, you want to keep your caps away. And I mean, if you really wanted to, you could move the resistors to the bottom of the board and you know, completely rework the amp, but they worked for this many years as is. Putting a higher quality cap in there is gonna, you know, allow them to work for a minimum of the same amount of time or longer, so you really don't have a lot to lose by leaving it the way it is and upgrading the caps. So I gotta get a couple of these monsters too. These are gonna hurt. These things are painfully expensive. especially when you get up into like the 1,000 microfarad range. Diameter on these is also important, so you got to make sure you're kind of sticking with the same size. And these are 30s, so you could go 25s and go a little bit taller if you had to. I'm going to guess that they have plenty of 30s in stock. LGU series, which is a great cap. So they have two different ones. They have LGU and LLS. They're both rated through. LLS is only 85C, so I'm going to go with the LGU series, rated at 105C, 3,000 hours. They're not too bad. About $5 a cap. We'll get 10 of these. Get a little price back when you order them in quantity. Alright, let's see what else we can do on here. So we got those on order. Let's see what these small ones are. I'm not even going to pull them if I don't have them. Of course I can't read. Looks 470/16, and these are the skinny 470/16s, and I don't think I have those. I know I have fat 470s, yeah. So I'm going to order some skinny 470s as well. And what I'll probably do is I'll probably finish part one of this repair early, just because I have so many parts that I have to order. I will check and make sure that I don't need anything off of this board. Oh, I don't know, maybe I'll recap that board just to see, in case I need more parts. But I need some skinny 470s, so we're going to have to add those to the cart as well. And I believe those are 16 volt. Yeah, 16 volt. So that's the same as this guy here. Same package size, just different cap. Credit card's going to be screaming when I place this order. Alright, I believe that these might be the ones that I have to order as Rubicons. That's like my second choice in cap. And they're both equally as good. If you read about them on the Bad Caps forums, they're both tier 1. It just boils down to personal preference. It really doesn't matter. Whatever you can find in one size, if you can't find it, the other one generally has it. If not, then you can go on to Panasonic or one of the other popular brands. Just don't buy garbage capacitors. That's the only recommendation I can make. I don't care what you buy, just don't buy garbage ones. So these look like they are 8 in diameter. Lead spacing is going to be 3.5. Let's see what we get. So it looks like they do have UPW in that series. I don't know how tall they are. We're going to find out. If I can get the UPW in bulk. I don't like ordering cut tape too. Whenever you're ordering caps, try and get them in bulk. These are 15 millimeters high. It's probably going to be a little taller than these. Yeah, a little bit taller, about 3 millimeters taller. But the diameter's right, and we have the space on the board, so we're going to get those. But yeah, whenever you can order caps in bulk, get the bulk ones. Don't get the cut tape. Cut tape is terrible. Just takes too much time to process them and get them all organized. We'll get 50 of these because I know I'm going to need them. And the the skinnier versions are used on multiple places on these boards. We got lucky and they fit on the little daughter boards on the amp board. Sometimes you get lucky, sometimes you don't. Just it's kind of a crapshoot. Alright, I'm going to leave this board for now. These last ones I believe are 47 at 16 volt, and I have some of those, so we're good. We're going to move on to the input board. See what we have here, see what we can get done and recapped, and after that we'll call it a day. This one's a little more challenging just because it's so hard to get into the area to actually pull the caps. These 220s are an oddball size. This is a case where you can go smaller though, and it doesn't really matter. So let's get in here and start yanking all these out. And we got a little add-on here. There's a couple of ceramic add-ons on the bottom. Certain revisions of these boards have different modifications on them, so keep that in mind too. Keep an eye out for it. Just heat it and lift the legs off. And I'm not working in any specific order, I'm just kind of going where I can get to. Most of these orange ones are going to be 4.7 at 50 volts. I should just get that bin out and leave it out. Could probably zoom out a little bit too. Zoomed in way too far. Still haven't found a nice like head mounted or wall mounted camera to make the views any easier. Still working on that. I thought about trying to use a boroscope, but I can't find one that's like a short length and that has high definition video on it. And I don't want to spend a ridiculous amount for a camera that may or may not work. And I need something that'll give you like a first person view through my eyes would be the best view. Maybe I'll get some glasses that have like a little camera mounted on them. Then you guys won't have to stare at the top of my head while I'm trying to explain what to do. That might be the best way to do it. Again, be careful of the wires. It's going to be kind of tight working in here. Again, a lot of these caps on here, 85C rated. Now this really isn't a hot area, but I don't know. I generally like to use the higher quality caps when I can. So this is 220 at 25 volts. And it looks like I need to order some of them too. Today is a hit or miss day. Alright, back to the ordering form. Bear with me. We're doing a full inventory restock today. I need to get somebody on the payroll to manage my capacitors. Pay them 1 day a week to come over and just order everything for me so I don't look like an idiot when I'm trying to make a video. So we will replace this one. I'm going to order the same size. 10 diameter, and lead spacing is going to be 5. And this is a UPJ series because it's a weird size. Lead spacing 5, diameter 10. Oh, that's not good. These are non-stocked. These are 5,000 at 105C. Alright, well we can't go with UPJ. We gotta go somewhere else. Those must be discontinued. Let's do 2,000 hours at 105. Also obsoleted and non-stock. That's no good. See, when you run into these weird sizes, this is some of the stuff that you start to run into. It becomes hard to find parts. So I'm going to get rid of the size and see if I can get rid of the lead spacing. Get rid of the temperature and see if I can find a cap that'll work. We'll go back to 5mm on lead spacing. They have some UVPs. I don't remember what I think those are only 85C rated. Yeah, those are only 85. Sometimes you got to use 85s. You know, if you can't find it in the 105 and you need a specific size, you know, that's what you got to do. It's unfortunate that it could just be that they're out of stock on them too. But I'm not going to a different vendor. I'll just find one that matches. I know URS series is pretty good. I've used them before. So I'll tell you what I'm going to do. I'm going to clear my filters on these. And we're just going to go by diameter and see what we can find. Diameter is 10, so I will do 10 on the diameter and see what options I have. I can't go 8 because the lead spacing will be off. Looks like URS is an option. 2000 at 85C. UPM. I have not used those. Let's see what UPM is. UPM is 5,000 at 105. General. All right, we'll try these out. I haven't used those before. UPM series, that fits my diameter requirements though. Lead spacing is, I hope, 5 and 10mm diameter. What's the height? Height is 14. Alright, I found a match. And we got our temperature rating. So we're going to go with a UPM series. Try them out. Should be just fine. It's a Nichicon cap. 5,000 hours at 105. Sounds good to me. And I believe these are power supply filters. They're not in the audio path, so we're going to make sure we use a high quality cap. I'm going to get 20 of those to try out. Which means that this guy is not going to get installed because I don't have a match for him. The UPJs are out of stock, so I'm going to pop this guy back in. And we will move on to the next one. Hope you guys are having fun. So more parts to order. Alright, let's continue. One microfarad at 50 volts. These are, they're made by S.Y. I don't know who that is. I don't know if they're any good or not. I wouldn't trust them because I don't know what they are. One at 50 volt UPS series. And again, these are still 85C rated, I believe. No, this is 105. And it's non-polar. Good thing I actually double checked that. That's another thing too. When you're replacing these caps, make sure that you check, and especially on the input board, make sure you're checking for the polarity on them. If they're bipolar caps, you want to make sure that you're putting a bipolar cap back in there. That will make a difference. Generally speaking, the where the BP marking is where the negative side of the bipolar is. They're not really polarized, but the outside can add some noise. Generally, that's more important on tube stuff. If you watch Mr. Carlson, you'll notice he's always talking about the outside foils on his capacitors. Well, it makes a difference there. I don't really know how much of a difference it makes on solid state gear, but I generally try to put the BP marking where it belongs. So yeah, make sure you're checking your caps too for polarity. That's just as important as the quality of caps is the type of cap too. Sometimes you get lucky and it'll work if you make a mistake, but I don't think my customer would be happy with me making mistakes. So this one right below it, I mean, let's zoom in on these. Show you how easy this is to miss. Come on, camera. Focus. I don't think I have a manual focus button on here. Wants to focus on the amp. But anyways, I mean, you can see how small these are. Give me a second, let me get up manual focus so you guys can actually see what the heck I'm talking about. It's going to drive me nuts if this thing is still blurry. By the power of computers. Alright, so you can see, I mean, these are the same size, same shape. They're both rated for 1 microfarad, same voltage. This guy has tiny little letters on them that say NP. Alright. That's about as far as I can go in. I don't know if you'll be able to see the letters or not. But right on the top, NP. This guy has a stripe on him. Non-polarized, polarized. Same cap, same voltage, same rating, 2 different styles. Don't confuse them. It's very, very easy to do. That's your other pro tip for today. Got to make sure you're on top of your game when it comes to that, because it is extremely easy to miss. And as you saw a few minutes earlier, I almost missed it. So don't be like me and make mistakes. Put the right caps in from the start, and you won't have any problems. And that's also generally why I don't throw my caps away as I'm working on them. I leave them on my bench, and if I have to look at them and realize that I goofed on something, then I can at least go back and figure out what I did and fix it. So it does make a difference. Alright. Let's continue. This one has a bent lead, it's going to be a problem. Oh, actually no it doesn't. Bent lead is for another component. 4.7, 50 volts, polarized. Check our values, make sure they're good. Another thing you gotta look out for too is caps that are not populated on the board. I highly recommend doing these one at a time always. If you pull them all out and you're working on a board that doesn't have certain areas populated on it, you might end up throwing a cap in there, by mistake. And it could change, the total operation of the amplifier. So I find it's much better to do them one at a time. You're less prone to making even more mistakes, and it gives you a chance to check your polarities and kind of go through and make sure that everything else is good. So some of these, when you start getting down to the bottom, get extremely hard to get at. Just got to be careful. Try not to burn your fingers. It's okay to heat them and give them a little bit of a wiggle to kind of free them up. Alright, this one is a 4.750, 0.4750 volt. And I know we have some of those. Those are pretty popular. Just double check our values. It is polarized, 0.47, 0.47. Pop them in there. Some of these are increasingly difficult to solder depending on where they are. If you got to put a little more solder on there to actually get it to cover the joint, go ahead. And then just do a quick little drag to leave you your nice little fillet. As long as you have a decent connection. This one down in here that's covered with glue, that one's going to be a pain. So we are going to have to peel back a little bit of this glue just to get one of these guys out down here. And I'll show you right down in there where some of that is. Luckily this stuff comes out fairly easy. I'm not gonna, I'll probably slice it so I get a nice clean cut with the razor just to make it a little easier to get out. But let's keep going. I got a few more to do. Sorry if you hear my dog barking. It's going nuts right now. Mailman's probably here. .750 volts. Feel free to leave any questions you have in the comments too. I try my best to answer them. Like I said, I've been away for a little while. Had a lot going on, some health things going on, but things seem to be kind of back to normal now. So. Oh, here comes the dog. The nosy dog. Wondering where I am because I was not home to greet her. Or I was not upstairs. Hello, dog. Doesn't feel like making a video appearance today. Just wanted to come and sniff around. Alright, let's solder this ceramic back on this one leg down here. We're getting to the point now where we have some ceramics that are over the top of some of these legs, so we kind of got to be careful pulling these off. Again, it's a little hard to see, so I'm going to flip this up here, and you can see it's this guy right here. For whatever reason, they've added a ceramic cap across these electrolytics, so just kind of pay attention to where they are and how they're oriented. If you can leave them on there with the glue, that's the best. just desolder the electrolytics and kind of work around them. I mean, they have huge solder blobs on there, so sometimes you gotta take it all off, but it's easy to forget to where they attach to, so I mean, that's what you really want to avoid. If you have to, do one at a time. And .750 volts. I'm actually going to leave this one out. We're going to do the one below it first. I believe the one below it is also a 4.7. I'm going to do these both at the same time because the ceramic attaches to both of them. I'm putting a little extra solder on there to try and help me get it desoldered. If you wiggle it a little bit while you're solder sucking, you can generally get the cap to come free, and the other cap will stay in place and behave. It's kind of a way to cheat. 4.750 volts. But here, let me show you guys this. I'm sure somebody are going to want to see it. But this ceramic cap is glued down. So I don't want to fully remove it because then it's a pain and I don't really, always remember where it went. So if I can just leave it in place and not have to pull it out, I can just undo the legs where the electrolytic was, leave that guy in place, and then just re-all tack it together. And once it's soldered on, I know that I have it in the right spot. You could also take a picture of it if you wanted to and pull that off, but I don't know, to me it's just easier to leave it in place and fix the leads if I have to when I'm putting the replacement cap in. I don't have cap maps yet for the SUNFIRE series. That's actually not true. I have a cap map for the MK2 in the architectural series. For the HRS and the SDS amplifiers, I do not have capacitor lists for. So I generally I try to be a little extra careful when I'm working on those because I don't have an easy reference to look up where they go. And once I start doing more of these, I eventually will update that, but right now I really haven't had a need. I don't really like the way that they put that huge blob on here either. So one of the things I'm going to do is I'm just going to kind of push that ceramic down a little bit and make sure I get him tacked in, but you don't need a massive blob of solder on there. I'm going to use my little kickstand to hold this in place. You won't be able to see this because there's going to be a bunch of stuff in the way, but all I'm doing is I'm just putting that ceramic cap back across that electrolytic cap, and at the same time I'm making sure that there aren't any shorts in that area, because those leads were kind of close together, and it kind of defeats the purpose if you have a short going across. And I can see that when I soldered it in there, it did make a short. So and that's not because of the way I did it, it's because of the placement of the cap. So what I'm going to do is move that one leg to the other side instead of having them both be on the inside. Let's see if I can capture that. So instead of having this leg, it might still be soldered. There it is. Instead of having this leg of the ceramic on the inside of the cap here, I'm just going to move it to the outside. And again, I'm going to have to do it where you can't see this, but just kind of hear what I'm trying to do and maybe it'll make a little more sense. But just moving it a little bit so that any chance of having a short is minimized by just getting that leg away from where the other leg is. And if you have to put a little bit more solder on there, so what? It's not the end of the world. You can see this cap got raised way up. So I'm going to heat that back up. Pop him back down in there. These like factory reworks are always a pain to deal with. But if you deal with them the right way and improve what you had, you'll be in good shape. So now I'm verifying there's no short. The cap is connected back to where it was. I don't have a massive blob of solder on there like there was. And I'm going to go ahead and put this other cap in. Check your polarities too, just double check. We're good on both of these. Stuff like that makes this kind of tedious, but in the long run, you end up with a better repair, so it's kind of worth it. Got kind of a big solder blob on there. Be willing to make some mistakes too, that's going to happen. You're going to make a mess, but it can always be repaired. It can always be fixed. You don't learn if you don't try. Alright, so we're halfway through. I have, I don't know, about 10 more to go on this side of the board, and then I have this one troublemaker down here that we're going to get to. And once we get to that, we will be in good shape. I won't be able to, you know, put this back together or test it, unfortunately, but maybe in 2 to 3 days, we'll be in good shape. It's unfortunate. I see there's a ton of silicone on some of these other ones that I need to get out. Which kind of sucks, but we'll have to get through it. 4.750. I know the one in between the pots down on the bottom is a bipolar, because I believe that's part of the phase control. I think it's time for a new soldering tip. This tip is not holding solder nicely. Also helps if it's facing the right direction. And we'll just keep working through until I reach over to this section here, and it looks like I have 3 of them that are going to be blocked by the silicone stuff. So at first I'll try to just heat through it and see if I can burn it off. That usually is very unsuccessful because silicone has an extremely high melting temperature. Sometimes you get lucky, sometimes you don't. We'll have to just see what happens when we get there. few more to go. But you can't really take this board out. I mean, you can, but it's really not worth it. C32 on this board up at the top is a non-populated spot. So if you're working on one of these and you see C32 and you get confused, just remember that that did not have a cap there. I actually might switch tips to my pointed tip. This is just becoming too hard to get into these areas to solder them. One of the benefits of having one of these Hakkos, and this is the cheapest, oldest one you can buy, but I love this soldering iron. This is a great soldering iron. Tip changes are real easy, real fast. Now I won't get as much heat out of this one as I do the other one, but I can get in there and I know I'm getting good joints. Alright, we have two more here, two black ones. And you can clip the leads in between too. I generally do them all at once, but if they start to get in the way, I will cut them. I would not recommend doing one of these boards without a solder sucker. If you tear off one of these through holes on here, you're going to be screaming. 2250 and polarized. Very popular clip cap, not so popular on SUNFIRE. 2250 polarized. This one seems to have most of the negatives either pointing down or to the left. So that's another thing to keep in mind too as you're checking your parts, making sure you're putting them in right. You can sometimes just look at how the other parts are oriented and get them in there. I am going to cut some. I'm going to just snip these leads now because they are starting to get annoying and get in the way. I generally leave just like a tiny little nib sticking out. Just cut them right at the top of the fillet. I cut each lead individually. So I can control where they're both being snipped. If they're soldered onto more than one component or it's like a board rework, I usually cut them a little bit higher just to give it some extra support for that rework joint. It's just kind of a, I don't know, something you learn as you go. Certain joints are more prone to failure than others. You definitely don't ever want any cold joints. That's primarily why I use leaded solder. Some people are dead set against using leaded solder. I use it for everything. I see no reason to use lead-free solder unless it's something that, you know, a kid could chew on. You just get a much higher quality joint, and I don't think there's any risk of doing so on this type of equipment. 2250 polarized. This is one of those weird configurations where they had the cap marked for a bigger size, like the board is marked for a cap this size, but they used one of the small 5mm caps on there. It must have been a last minute change or some reason they went to the larger package. In that case, you could put, you know, if you had one, you could put a larger footprint in there. I don't have any, so I just did what they did and fit the smaller one in there. Check our polarities again, and this board has little notches on them that are marked. And, you can see on the top of the board here, this is not populated from the factory. So don't get confused and put a cap in there on accident. Just know that it was never there. Your board might have one though. I can't promise you that they'll all be like this, so pay attention to that. And this one had some reworks down here from the factory. It looks like they put resistors. Actually, those are jumpers in the place of those two caps. So I don't know. One thing I've noticed is, like, if you have a signature edition, they make little changes. They're all the same boards, they just make tiny little changes to the circuitry, and that gives it, you know, 50 more watts or whatever the signature version had over the basic version. So little things like that to keep an eye out for. I love how they put LEDs on this board. You can't see them. You can only see them if you take the amp out of the box. Alright, we're starting to get into the area where it's getting a little more difficult to work on these. This is 47 and 16 volts. Double check, 4716, make sure it's not 4.7. I believe this is for the auto on-off function, this guy here. If you have problems with your auto on-off circuitry on any of your subs, it's generally a bad capacitor. Because the way that those circuits function, typically, is they use a very high ohm resistor to charge a capacitor. And when that capacitor charges to enough voltage, it turns on a transistor, and then that's what turns on the rest of your amp. And almost all of them function that way, so keep that in mind. We might have to pull the transformer. I might just do it to make it a little bit easier, because I'm starting to get into this area where this glue is going to get annoying, and I got to get these last 6 caps on this side replaced, so I might just pull the transformer off and get it out of the way. Can't disconnect it, unfortunately, but we can move it. And I'm not pulling that board off. I've done that before. I had to actually replace the RCA jacks on an amp that I was working on, and that is just no fun. Pulling a transformer, not too bad. I think these are the harder of or the more difficult amps to work on that are made by SUNFIRE. I think the higher end amps are actually easier to work on. But we'll move the transformer, make it a little easier to get in and out of there, and hopefully just get this section of the board done. Don't take all the screws out with your transformer standing up either. because it will fall down and probably damage your board, and then you'll be fairly upset. I don't like how these were mounted either. They should have had the nuts welded to the bottom of the transformer. That's how I would have preferred to have it. This one has washers on it. The other one did not. That's weird. Maybe it did, because I just heard a washer fall out. We will have to find that. I think it was underneath the transformer instead of on top. Either way, the washers are undersized for this application. You can see the transformer already wants to move. Not all the screws are loose, so that gives you an indication of how heavy this thing actually is. So try to just get the nut off. Don't take the screw all the way out. Then find a way to orient this thing so you're not going to drop it on anything. We got one more to go. So if we set them like this, the only place it can fall is onto the desk, not onto our circuit board. Now you don't always have to do this. The primary reason I am is because of the glue. There are other easier ways to get the caps out, but there's just so much glue on there, and I know it's going to give me a hard time, so pulling the transformer will be a little bit easier. Alright. It's nice that they used little rubber pads to keep that guy kind of mounted without vibrating on the plate. But now that that's out of the way, we have much more room to get in here and do what we need to do. Let's zoom out a little bit. Yeah, at the expense of a few more minutes and some screws, it's worth it. And we continue. I believe most of these are going to be 4.7s and 50. I have one of these. I'm going to be doing an HRS 10. Probably in a week or so. I have one that I don't know where it came from or how it came. All the wires inside were snipped. I had to completely rewire the whole inside of the amp. But I think I'm at a point where it's almost back to life. My guess is it was probably a store return somewhere and they had to damage it before they threw it away, so they said, well, we'll just snip all the wires. Somebody dumpster dived it and then sold it to me. That's fine, because it's still a $200 amp, even if it's got wires cut. Just repair the wires and it's back to being good. 4.750. One thing I learned, you won't get rich repairing amps, but it is fun. And nobody does it anymore, which is even cooler, so you make a lot of friends in the community when you can repair their equipment. Used to be able to get parts to do all this stuff locally. There was a really awesome electronics store, like just one city over, and they are long gone now. Alright. Radio Shack was cool, but they never had all the parts you needed. Now we're at the point where the glue is going to start giving us headaches. Or silicone or whatever it is. It does come off pretty easy, so I'm not like terribly worried about it. It's just time consuming to have to dig through this to get it off just to get to the caps. It's nowhere near as bad as the glue that I have to deal with on clip stuff. That's evil glue. This is like nice glue. It's not even glue, it's silicone. Alright, there's one. You can leave a little bit on there too. Some of it will burn off. $4.750. I keep these little dental scrapers handy. So after you get it off, if you want to get some of that excess silicone out of there, you can. I'm going to try and scrape around this other cap. Sort of unsuccessfully. But somebody wanted to make sure this board never came off, so I guess they did a good job. The board won't come off and the caps don't want to come off either. But it's not too bad to work with. I mean, I've dealt with worse. Any residue on there, the flux that's in the solder will clean off. I only use rosin core solder. Check our polarities. This one is opposite than most of the other ones, so keep that in mind. It is marked on the board. Good solder joint. We will cut the leads. And move on to the one below it. This one I did not do nearly as good of a job of cleaning. And because of that, I clogged my iron. So we got to take a minute and clean this thing out. After you stick this guy in there, don't touch it with your hands. You'll do that once and never do it again. I'm going to try and get some of this silicone off there so I don't jam my tip again. Alright, 10 microfarad, 50 volt. That one's a little different. Make sure our polarity is good. It's a UPS series, but it's a little bit different color. There's a little solder blob on there. I'm going to make sure I pick that up. And I'll show you guys what this looks like after I get these last two replaced. And then we'll be in good shape. All we got to do is get our missing caps. So I'll throw this guy in a box and probably take a dinner break because my wife is probably starving and wants to eat. And then we'll be back with something else. Another 4.7 at 50 volts. And we got that one troublemaker that's at the bottom down there that's going to be difficult to get to no matter what. Save the best for last, right? That actually is a polarized. I thought it was going to be a bipolar, but it is polarized. I'm surprised. I thought there were more bipolar caps on this board. There was only one. I know on the other ones there's a lot more. Maybe those are the ones that were replaced with jumper resistors. I don't know. I thought there were more though. Glue's a little thick down here, so it's going to be difficult to get off. Let's see if I can. Here, we can use the transformer to prop this guy up, give you a little bit better view. I'm just taking my little wooden skewer here and just upsetting the silicone. You're not going to get it all off, but you just need enough to get in there with your iron and get the cap out. That's really all you got to do. So you can take your tweezers and kind of grab the things and pinch it off, scrape it off, however you got to do it to get that stuff out of there. And you only need to remove it around this cap. You don't really need to take any of the other stuff off. You can if you want. I mean, I don't know. It's a little overkill. They really are just trying to seal around the RCA ports so there's no air leakage, which is a good thing, but I mean, they went a little crazy with the sealing if you want my honest opinion. Alright, I'm going to try and just heat this. Let's see if I can get it to come. Yeah, that's not going to happen. Not with that tip. I need more heat. Let's see if I can get the solder sucker in there on a weird angle and I just noticed I have a crack in my solder sucker tubing. I'm going to have to do a repair on that later. Got a vacuum leak. Alright, so the cap is loose enough to replace. I'm just going to try and get some of this gunk out of there. Just scrape it as clean as I can just so the resolder doesn't get any contaminants in it. And that is a 2.2 50 volt polarized. I know I got some of those. Alright. I'm actually going to push him back out. Clean that up a little more. Chances are, if you're doing this repair, you could probably leave that guy in and not replace it, but since I'm doing this for somebody and it's not mine, I am obligated to replace all the caps. But as far as cap failures go, if they were going to fail, this would probably be one of the last ones to fail. Unless there's something I'm missing on these. Alright, that's it for the small cap repairs. Check and make sure that on our reworks we don't have any shorts. We look good. Our leads are all trimmed. Here you can see where it's struggling to focus. I just dug a little bit of the silicone out on this massive overshot here, and just a little bit down there. And the input jacks are over here, so they're still perfectly sealed. You don't have to worry about an air leak. But it's really not worth the time to clean all that up. It'll never become conductive. So, in my opinion, I would say just leave that in there. And you can see, you know, they did a good job sealing this, so I see no reason to try and pull this board off, and it's just going to make way more work for yourself. So I'm going to go ahead and put this transformer back on, get the bench cleaned up a little bit, and take a break, and then I'll be back again a little later on, or with another repair. Let's see here. Alright, well, I appreciate you guys tuning in. Remember to like and subscribe. I'm going to order those parts that I added to my cart here for this guy, and hopefully 3 to 4 days. I hope before the end of the week. I'm going to try and overnight the parts, so hopefully they'll get here and I can get this repaired and back to the owner. I'm sure they want to get their system back up and running. So stay tuned for a part 2 on this HRS 12, and I will see you guys all soon. Thank you for tuning in. Hit that like and subscribe button, and I will